Hi, my name's Christian Kortenhorst, and I'm a member of TOG for the last few years. Um, I started this project around 3 months ago, um, in relation to trying to reduce the amount of power that our office was using. So I started looking into what was using the power and how much power we were using, using a cheap power meter. Then I started looking into offsetting the power against what we were using, maybe using sun or so I looked into solar panels and started to get quotes from companies. And it just seemed very difficult to get anybody that wanted to do it, or they were too busy, or so, and the cost was predominantly quite expensive. So um I thought, let's try do it ourselves. Um so I'm no way an expert in this area, but I've certainly learned a lot over the last few months, and it's working well for us. And it's definitely I'd recommend it to anybody that's thinking about doing it to go the DIY route. So you need a number of things. So firstly, because we were on a commercial roof and we needed a cherry picker and the likes. We got a roofer who had done some work on our roof before to install them. He'd never installed them before himself, but he had a bit of cop on, and he kind of understood it, and the manuals were very easy to follow. And then our electrician obviously understood it, how it worked, and we had a number of tutorials on how to do it, from the crowd who we bought the kit from, and then the solar hardware you need. And then one thing that wasn't supplied and we kind of had looked at was monitoring of all of this. So we opted for a Shelly 3EM, of which I'll go into more detail in a bit, how it works and how we pulled out the monitoring of the power from solar panel and the general usage that we were using. It's really recommend it for anybody. Now this is a 3-phase version, but they also do single phase, and I'm pretty sure it can be configured to monitor different, not phases, but different inputs on your board. So I've broken this down into pretty much 4 different sections. So you've obviously the array that's on our roof. We went with 12 panels, which is 4.7 kilowatts. Then top right hand corner there, you've a fireman switch. So that's cut off, so that if power gets cut to your building, the power that's generated from the solar panels cuts off any input to your board or back onto the ESB, so that in the case of anything going wrong, or somebody working out on the line on the road doesn't get electrocuted. And then you've got the inverter, and isolator switches from the panels on the roof, and then bottom left hand corner is where it's plugged into the actual board. So how because we have a 3-phase system, it's slightly more expensive to run, to buy the kit, and it's a bit more expensive to install also. So but as a whole, it's pretty straightforward. So we've 3 breakers there, of which is the output from our 3-phase inverter, and that then feeds 1, 2, and 3 into the board, down there at number 7. So it's literally from the inverter into the board, so then this is our setup here. So you've got the inverter that does the conversion from DC to AC, and takes direct current obviously from, and then converts the 240 volts from the roof into AC power, and then splits it over the phases and we have two arrays that I'll go into a bit more detail on. But the fireman switch, as I discussed, that's the cut off switch. That's the green box there. That has to have permanent power from your board. So again, if that goes off, nothing works. And it's a safety mechanism. And then you've got obviously your DC isolator and your AC isolators. So then we've got our panels on our roof. So we have an insulated Kingspan roof, so very easy to install. Some tech screws into the tops of the roof, and it literally 2 hours and all the panels were installed. It was actually the electronics that took a little bit longer to install, but once it was installed, the guys flew it up, and then we drilled a hole through the roof and sealed it off. And again, the roofers did all of this. They were very skilled guys. So we have a 6x2 array. So the reason we did that was if you've any form of shading or bird poop or anything on one of the panels, you get an effect on across all the array, each panel. So if you've any form of shading, you definitely split them. So we had 4 cables going to the roof, the input and output. So we call them array 1 and array 2. So that's the top set of panels, and then the bottom set of panels. And then so if we do have any issues, then we can isolate an array. So this is the output of the power that we get. So top right hand corner there is the Shelly unit that we get. So that's our usage throughout the day. I think that's a month or weekly view there. So obviously they're A, B, and C phases. You won't have that in a home setup, but we do in the office, and then the total usage throughout. And then on the left hand side there is the output of the data logger. It's a little dongle that goes into the inverter, connects to your Wi-Fi, and that also logs up to a website. It's quite interesting to see. So our max power that we're getting out of the 4.7 kilowatts, I'll explain this a bit further, or my theory of why we're getting so little out of the 4 is 3.5. So firstly, we only set this up in the last 2 months or so. Our angle is not really the optimum on the roof. It's only 10 degrees, and it should be more like 30 degrees. Our max power daily that we've generated so far is around 16 kilowatts. But that could be anything as low as 2 or 3, depending on the day, if it's raining all day or it's cloudy. So it still does generate stuff, but it's our average usage in our office around 30 kilowatts. And we've around half a kilowatt that we use without anything going on. So that means we still have on the weekends and stuff, we still have some usage, but that's cancelled out by the solar normally. So what we're finding is winter months, certainly these months, we're getting probably a tenth of what we got. Now certainly the panels themselves aren't at the right angle and stuff, so we're looking into what we do with those, or even just adding more panels. So then as for the costs of the overall system, so this is what we ended up spending. So the electrician, plus a few bits of hardware that he had to supply, so trip switches into the board, and the spur power for the fireman switch, we spent €400. The roofer was €500. That included the cherry picker, and the solar panel themselves was a kit supplied by Solar City. So they're a crowd up on the north side. Really good to deal with. Send them a photo of your roof, tell them what you want to get, and they'll send you back exactly a kit, what you need to buy, and it's really good service. so our what it looks like is we're saving around €150 a month on our bill. Um, and that's without the buyback into the grid. We've yet to kind of, I think next June is the next time so there'll be a payback into the grid. But I'll talk about some other systems that we're looking at doing ourselves because the payback will be nominal. I think it's 16 cents a kilowatt now, and you might be paid 2 or 3 cents. So it doesn't really make sense to put it back into the grid. So then that's where batteries and things come into play. So we estimate 2 to 3 years, but again, I'll only know kind of this time next year when we've been running for a year. What's our savings? I mean, at the moment, certainly on a sunny day, between 9 and 5 when we're in the office, our meter doesn't move as such, so it's pretty good in that sense. It's the after hour stuff or days that it's just not. So yeah, and then as I mentioned before, the estimates are just very expensive from third parties because I feel that the grants and things out of which we don't get for being a business kind of didn't make sense. So then future plans. So looking at adding 6 more panels. So this is a kind of a trade off. We can add 6 more panels, because the second point there about mounting panels, what angle do you raise up the angle of the panels and try to get more efficiency out of your panels, or because the panels are so cheap nowadays, do you just add more panels? For I think it's €100 a panel, and a bit of time for the roofer. You can just very much and you just click them into the next one. So we'll have a 12 array, and then we'll have a 6 array. So we'll end up having 18 panels on a roof. So then I'd also like to monitor the panels. So I know that inverter has its own monitoring, but if we could monitor each individual panel or monitor the output on the same Shelly system, then you could overlay kind of what's being used and and really monitor it. So then I mentioned this before, the excess power, so that you can dump into your immersion. So because we're a 3-phase system, what we can find is there's one phase is using 2 kilowatts, and two other phases are using half a kilowatt. So because how the inverter splits the 3 kilowatts that you get off the roof into one and one, you could be feeding back on two of the phases back to ESB, whereas realistically you should be dumping that back into, and hot water seems to be the kind of the best way of doing it, and then modifying the angle. So yeah, a few more ideas on what we do. So then as for that, yeah, any questions, or let me know, and I'm always available to receive any emails or calls if you have any questions. I'm no means an expert, but I've certainly learned a good bit over the last few months installing it and managing it. It's been interesting.